All right, welcome back. This is the answers for two even problems on your homework. At any point, if you need help with your homework, please email me, chat with me, do something, get in touch with me so we can go over particular problems. If you let me know, we can do them as a little mini lesson, add another little video if you need me to, but we just got to do whatever we can to get through these. I appreciate all you guys who did the first section. At least a lot of you guys at least viewed the video. Hopefully you've done the homework and gotten help from whoever or whatever you can do to understand it. Our next lesson is going to be about analyzing data. A lot of this we've done, or not we have done, you've done in the past, and it's just remembering definitions. All right, the mean. We're going to be given a set of data. What we're going to do is have to find a whole bunch of different little things about it, and the first thing is the mean. The mean is the sum of the data values divided by the number of data values. Two symbols that are going to denote mean are going to be x bar and mu, a little u. Mu is another Greek letter. All right, x bar and mu are going to be your variables that you will see that will kind of give you, not really variables, just notation that tell you that you're trying to find the mean. Basic idea, add up all the numbers, divide by the total number of terms. All right, the median is your middle value, or the mean of the middle values. If you have an even number, you're going to have two middle terms, which are going to be your middle. You're going to take the average of those two to find the middle of those. The mode is the most frequently occurring value. If you have a set that has more than one sevens and that doesn't have multiples of any other number, 7 would be your mode. All right, you're allowed to have two modes. If you have two modes, we're going to say it's bimodal, two modes. You can't have more than two modes, so if you have a set that has 10 numbers in it and they all occur twice, it's not going to have a mode. And you don't have to have a mode. If every number is only one time, we don't have a mode. All right, so mean is your average, median is the middle, the mode is the most frequently occurring value. All right, so we're going to do this for the first problem. We're going to find the mean, median, and the mode. All right, to find the mean, we're going to add them all together and divide by the total number of terms. So, on a calculator on something, we're going to go 2.4 plus 4.3 plus 3.7 plus 3.9 plus 2.8 plus 5.4 plus 2.8. We're going to hit enter and get 25.3. And we're going to divide that by 1, 2, 3, 4, 5, 6, 7 terms. And get an answer, 3.614. We always round to 3 decimal places unless it says otherwise. But when you do this, make sure, double check, and I'm doing that on my calculator now, that I typed in these numbers correctly. Drop this down. All right, 2.4, 4.3, 3.7, 3.9, 2.8, okay, so we're good. All right, there's my mean. My median is we want the middle term. To find the middle term, we're going to have to put them in order. At any point during the lesson, if you want to kind of work ahead of me a little bit instead of me just going through it without stopping, pause the video and do what you need to do. But here's my set of terms again in order. All right, so looking at this, since there's 7 terms, my middle term is going to be my median, which is 3.7. All right, looking at my mode, I don't have, oh, I do. 2.8 occurs twice, so my mode is going to be 2.8. It's the only number that occurs twice, so I'm going to say that 2.8 is my mode. So my mean, I'm going to add them all together, divide by the total number of terms, 3 decimal places if you need to. My median is my middle term, 1, 2, 3, 4, 7, so 3 on each side, gives me 37 as my middle, my median, and my mode is 2.8. Starting easy. All right, the next concept is percentiles. The definition of a percentile, the percentile is a number that divides the data into 2 parts such that the part below the percentile contains a given percent of the data. All right, a little confusing, but hopefully at some point when you guys have taken standardized testing, it'll say you scored in the 85th percentile, you scored in the 90th percentile, the 98th percentile, the 30th percentile. All right, so hopefully you've heard that idea before and may have not known what it means. What it means is if you scored in the 90th percentile, that means that you scored better than 90% of the people who took the test. If you scored in the 30th percentile, you only scored better than 30% of the people that took the test. 98th percentile means only 2% of the people did better than you. 98% of the people did lower. All right, so what we're going to do to find a percentile, what we're going to do is we're going to find the position that separates the data and then choose the next value in the data set. Okay? And when we get down to these, we'll explain it a little bit better. But we're going to find the position that separates the data, which is the percentage, and then we're going to choose the next value. All right, so we have all 20 of these. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20 numbers. All right, we're going to find the mean, the median, and the mode, and the value at the 15th, 75th, and 30th percentile. All right, so I'll go ahead and pause it for a couple seconds. Find me the mean, median, and the mode. Put the numbers in order to get the median. It helps to do that also to find your mode. And then add them together and divide by the total number of terms to get your mean. All right, go ahead and pause it if you need to. I'm going to keep going though. All right, numbers in order are these. All right, the mean, we're going to add them all together. Let me show you on Desmos how it's going to be a little bit easier. We can do some of this. All right, what we're going to do, let's get rid of all this other stuff I have. We're going to make a table. And in X1, we're going to put all of those numbers. Let me slide this to the side or down and figure out what they are. So I'm going to go 21, 24, and just keep putting them all in. I hope we can add together and divide. But let me show you when we get to an SOL test, a standardized test at some point what's going to be better. Make sure I got them all in. That didn't work. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 20 terms. All right, so we got them in. Now what we're going to do is we're going to let the computer find us the mean. So we're going to go in our next line, functions, statistics, mean, and our mean is what we want to find of x1. So we're going to go down here and do mean of x1, and it gives us 65.5. So I mean, that's not even doing the work, but that is math we can do. Median. We put them in order, so let's understand what it is before we let the calculator do it for us. So 20 terms. I want the middle is going to be 2 terms. It's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. My middle is going to be between these 2 terms. All right, and to find the middle of that, I'm going to add them together, divide by 2, do that quick math, and I get my median to be 64.5. All right, going back to Desmos, Get rid of this, and I'm going to do the median of, no, not there, of x1, which is my list, and it gives me that 64.5 that we figured out on our own. It's not going to do mode for us because it doesn't offer that. So we're going to go back to our list. I'm going to look and realize we've got 265s, 287s, but I have 398s. So 398s, I have the most 98s of any number. That's going to be my mode. So the mean, add them and divide by 20. The median is between 64 and 65, which is 64 and a half. My mode is 98 because it occurs 3 times. Those are the easy ones. All right, now, understanding percentiles. What we are finding is the term for this first problem is the term that has 15% of the data below it. All right, that's the terminology. The term with 15% of the data below it. That's what we're looking for this first one. All right, so first thing we have to figure out is how many terms is 15%. To find the number of terms that have 15%, that are 15% of this set of numbers, I want 15% of my 20 terms. To calculate this, I'm going to make this a decimal and multiply it by my number of terms. Plug in the calculator, and we get 3 terms. So 15% of 3 terms, or 15% of my 20 terms is going to be 3 terms. Now with that, what we want to know is which term has 3 terms below it. What term has 15% of the data below it? So looking at my list in order, there's 3 terms. This is 15% of it. So my percentile is going to be that next term. The 15th percentile is going to be the number 45 because the number 45 has 15% of my data below it. So we need to find out how many terms is 15%, 1, 2, and 3, and then take the next term because 45 has 15% below it. All right, 75th percentile. I'm going to do, for this one, 0.75 times my 20 terms, which is going to equal 15. All right, that's my math I'm going to do. All right, so the 75th percentile is the term that has 75% of the data below it, which is 15 terms. So my 25th percentile, that's 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. All right, this is 15% of my data from 21 to 87. So that means my 15th percentile is going to be that next term, 87. So we're finding the term that has that percent of the data below it. All right, take a couple seconds. Pause it if you need to. Find me the term in the 30th percentile, the value to 30th percentile. What term has 30% of the data below it? Pause it if you need to. So 30th percentile, 30% of my data, 0.3 times 20 is 6 terms. 1, 2, 3, 4, 5, 6. The next term is 57, so the term 57 has 30% of my data below it, so that 57 is in the value at the 30th percentile. So you find out how many terms it is, and then find the next term that's going to have that below it. All right, so we're going to do the same thing. This time we're going to do the 25th percentile and 75th percentile. So you're given these numbers. Find me the mean, the median, the mode, the value of the 25th percentile, and the value of the 75th percentile. use your Desmos, use your calculator, but you best, and you need to put them in order. That's why we do it in order so we can get these percentiles. So go ahead and start that. Pause it if you need to, put them in order. Find me the mean, the median, the mode, and then find me each percentile. I'm plugging them all in. Takes a couple seconds, but it's very important that you go back and make sure that they're right. You don't have the right numbers in, it's not going to work. All right, then I'm going to go down here and I'm going to go mean. Now I can't type it in, I have to use my function. Mean of x1, make sure it's still x1. 180.5. There's 16 terms, 2, 4, 6, 8, 10, 12, 14, 16 terms. All right, my median, 1, 2, 3, 4, 5, 6, 7, 8, is going to be between 180 and 180, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8. So my median is going to be 180 also. My mode, I have two 176s. I have two 180s. I have two 186s. That means I have 3 modes, which means I have no mode. You can't have more than 2 modes. Add them together, divide by 16 is your mean. Your median's the middle. The mode is what occurs most often, but you can't have more than 2. All right, value at the 25th percentile. To find what term, I'm going to do 0.25 times my 16 terms, which is going to be 4. So I want the term that has 4 terms below it. So I'm going to 1, 2, 3, 4. There's my break. And then my next one is 176. That first 176 has 4 terms below it, which is 25% of the data. For my 75th percentile, I'm going to do 0.75 times my 16 terms. Do my math, and I'm going to get 12. So I'm going to count that's 4, 5, 6, 7, 8, 9, 10, 11, 12. Take the next term, 186. So the term 186, this one, has 75% of the data below it. Change these to a decimal, multiply them times the number of terms, and that tells you how many terms are in that percent. And you take the next one because the next one has that many terms below it. All right, standard deviations. Standard deviations is going to be how each value in a data set varies, how it deviates, how it's changed from the mean. Big, ugly formula. All right, you don't need to know it. Just know that there is a formula that could do it if you need to. All right, so what we're going to do, we're going to find the mean standard deviation to the nearest tenth. We're going to round to 1 decimal place. And then we're going to state the number of standard deviations that include all of the data. So I want to know from the mean, if I add and subtract standard deviations, how many do I have to add and subtract to be outside of my maximum and my minimum value? How many standard deviations is it going to take to get outside of my data? All right. So for this problem, find the mean standard deviation. I need to put these numbers in order. And what we're going to do is we'll go over to Desmos. and do both of these. So I'm going to get rid of this one, get rid of this one. I'm going to make my table, put my numbers in, 46.6, 48, 49.9, 52.3, 53.2. They don't have to be in order, I just chose those numbers. All right, add them up, divide. Find the mean. Mean of x1 is 50. All right, the next thing I'm going to do is over here, we have standard deviation. And I'm going to do a standard deviation of x1. And I'm going to round that to one decimal place and call it 2.8. So this is, we don't have to do the math, we just have to know how to find it. The mean is 50, standard deviation is 2.8. The symbol you will see that denotes standard deviation is this little symbol right here. All right, so that's half of it. All right, so now what we're going to do is I want to know how many standard deviations it's going to take to include all the data. So what I'm going to do is I'm going to put my number 50 right here, which is my mean. All right, from that mean, I'm going to keep adding and subtracting standard deviations, adding and subtracting 2.8 to see how long it takes for me to get outside my lowest and my highest number. And you have to do it both ways. It's going to be 1 standard deviation, 2, 3 each way, and whatever the bigger number is to get outside of it is what we're going to use. All right, so I'm going to add 2.8, get 52.8. I'm going to subtract 2.8, get 47.2, which would be approximately here and here. Make these a little smaller. So if I add and subtract 1 standard deviation, it's going to put me at 47.2 and 52.8. Somewhere about here and somewhere about here. All right, there's still numbers outside of this, so what I'm going to do is I'm going to add it again and subtract it again. So adding again puts me at 55.6, and subtracting it, let's get calculators, don't have to think, 47.2 minus 2.8, 44.4. All right, so now I'm here and here. Am I outside my lowest and my highest term? Yes, so it's going to take 2 standard deviations to include all of the data. And that's what they want to know. How many standard deviations you have to add and subtract to get outside of your highest and your lowest. So you start at your mean, add and subtract 1, add and subtract 2. I'm outside of these two numbers, so it took 2 standard deviations. All right, try the same thing for the next one. Put them in order. Find me the mean, find me your standard deviation, put your mean where it belongs, and keep adding and subtracting till you get outside of the lowest and the highest term. All right, so I'm going to put them in order. I'm going to find the mean, go back to Desmos, get rid of this, add a table. Now I'm going to change this to x1, not x2 and y1. The y doesn't matter, just keep the x's. Move these numbers to the top so I can see them better. (21, 23, 43, 44, 50, 54, 87, 90, 90, 110. All right, got my numbers in. Tells me my mean, 76.25. Standard deviation is 46.5. 76.25 46.5. On a test, on a quiz, whenever they happen, we're going to have to be able to do these, do the mean by hand. Standard deviation is always a calculator problem. All right, so I'm going to bring this back down. Mean 76.3, because I round it to one decimal place. Standard deviation 46.5. All right, so now my mean is approximately here. All right, 76.3. So what I want you to do, add, subtract one standard deviation, put a line about where it should be. If you're not out here, do it again and do it again until you get out there. So 76.3 minus 46.5 is 29.8, which is going to be approximately 29.8. Let's call it right here. So that's my down one. And now I'm going to take 76.3. I'm going to add my 46.5, get 122.8. Which is going to be about here. All right, so this is adding and subtracting one standard deviation. All right, I've still got numbers on the outside. So I'm going to do it again. I'm going to take 122.8 and add 46.5, get 169.3. All right, which still, get a different color. Which is going to put me about here. And I'm going to take 29.8 and minus 46.5. Get negative 43.7, which is going to be somewhere down here, which is outside of my low. So I am good going down. 2 standard deviations takes me lower than my lowest value, but it doesn't take me higher than my highest value. So I'm going to do it one more time. Add it again. 169.3 plus 46.5, 215.8. Which is way out here. So it took 1, 2, 3 standard deviations to include all of the data. And that would be your next answer. 1, 2. I don't need to go down again because I'm already outside, but I had to go 1, 2, 3 times to get outside of 180. So you have to figure out from your mean how many you have to add and subtract. You have to do both of them to get outside of all your data, to include all your data. At any point when you're doing this work, if you have questions, email me, send me a chat, do something, get in touch with me, or find someone that can help you. All right, z-scores. Z-scores are used to compare data that isn't the same. It gives you the opportunity to compare apples and oranges. All right, a z-score is going to be the number of standard deviations we are away from the mean. Okay, it's the number of z-scores away from the mean. Your math is going to be your value that you're using, like 87, minus your mean divided by your standard deviation, and that's going to tell you how many z-scores you are away from the mean. When we get to this last problem here, we're going to compare SATs and ACTs, which are 2 tests that don't have anything to do with each other in terms of numbers, but we want to be able to compare them to see how you did or how someone would do based on their score. Because you just can't look at your ACT score and your SAT score and decide which one was better. All right, so a z-score is the number of standard deviations away from the mean. So what we're going to do, we're going to use the numbers from number 2. Where's number 2? All right, so I'm going to use these values. All right, for number 2, my mean is 76.3, my standard deviation is 46.5. I want to know the z-score of the value 87. So I'm looking for how many standard deviations 87 is away from the mean. That's what we're trying to find. All right, so our math. The number of standard deviations above the mean. All right, so my formula says my z-score is going to equal my value minus my mean over my standard deviation. So I'm going to go 87 minus 76.3 divided by 46.5. I'm going to go to my calculator. I'm going to go to decimal, so I'm going to go somewhere. 87 minus 76.3 divided by 46.5. And my z-score would be 0.230. So we are 0.230 standard deviations away from the mean. If you think about it, we're approximately 10 away. Standard deviation is about 46. That's about a quarter, approximately a quarter. So my z-score would be 0.230. It's your value minus your mean divided by your standard deviations. So we are 0.23 standard deviations away from the mean. All right, the next one we're going to calculate is the z-score for 50. 50 is below my mean. So when you're below your mean, you're going to end up with a negative z-score. Because that tells you you're below it. A negative z-score is going to tell you how many standard deviations you are below the mean. Doing my math, I'm going to be negative 0.565 standard deviations below my mean. When your z-score is negative, you're going to be below the mean. So I'm a little over a half of a standard deviation away from my mean. Your z-score is how many standard deviations you are from the mean. A positive z-score tells you you're above it. A negative z-score is going to tell us you're below it. All right, now going a different direction, we're going to give a z-score, and then we're going to figure out our value that is 1.3 standard deviations above the mean, and then we're going to find the value that's negative 0.9 standard deviations above the mean. And this needs a little bar over it. There's our mean of 83, standard deviation of 9.6, and these are your z-scores. So what we're trying to find this time, given the formula, is we're trying to find the value. All right, so we're going to go the different direction. All right, so using my formula, my z-score equals my value minus my mean divided by my standard deviation. So I'm going to go 1.3 equals x minus my standard deviation of 9, or my mean of 83 divided by 9.6. My z-score equals my value minus my mean divided by my standard deviation. Now I'm going to solve. I'm going to multiply by 9.6. 12.48 equals x minus 83. I'm going to add an 83. 95.48 equals my value. So what we have just found is that the number 95.48 is 1.3 standard deviations above my mean. 95.48 is 1.3 standard deviations above my mean. That's what my z-score is. How many of these I am away from my mean. All right, the next one, of z-score of 0.9. All right, do the math, see if you can find it. All right, so negative 0.9 equals x minus 83 over 9.6. Solve by multiplying by 9.6, add an 83, and we get the value of 74.36. Since my z-score is negative, I am 74.36 is negative 0.9, almost 1 standard deviation below my mean. All right, that's the math. All right, the next part is how it kind of all comes together. So we're going to say that you took the SAT and scored a 1010, which has a standard deviation of 218, and your ACT score is a 20.8 with a standard deviation of 4.8. All right, if we don't know, the ACT is another standardized test that is a college acceptance test. We don't use it as much in this area. It's used more on the West Coast, but it's similar to the SAT. It's just they ask you questions about everything instead of just math and English. All right, so we're going to say you scored a 1340 on the SAT and a 28 on the ACT. What we want to do is to be able to compare our scores to everyone that took the test. You just can't look at it and tell because they're different numbers. So what we're going to calculate our z-score for both of these tests, and whatever one has a higher z-score is going to tell us how we did compared to the group. All right, so my z-score is going to equal my value minus my score, minus the average, divided by the standard deviation. Yep. So I'm going to calculate both of them. I'm going to work both at the same time. Doing my math, 1340 minus 1010 divided by 218. So my z-score was a 1.51376. All right, so now I'm going to calculate my second one, 28 minus 20.8 divided by the standard deviation, and I got a 1.5 even. So my z-score for the SAT was 1.51376. My z-score for the ACT was a 1.5, which means this value of 1310 is a little bit further away from the mean than my z-score for ACT. So I did a little bit better, not significantly better, but just a little bit better on the SATs than I did the ACTs. All right, so the z-score is how many standard deviations you are above or below the mean. Positive z-scores are above, a negative z-score would be below. All right, so in this lesson, we need to be able to calculate mean, median, mode, find a standard deviation, and all of those really we're not doing too much work ourselves. After we find mean, median, mode, we need to understand what a percentile is. A percentile is what is the term that has a certain percent of the data below it. So for 15th percentile, we're going to find the third term. 3 terms is 15%, and then I want the next one. For the 75th percentile, I took 15 terms, and I picked the next one to be that percentile. So the percentile is a term that has that percent of the data below it. standard deviations calculator does for us, and then you calculate how many standard deviations it takes to get outside of your values. And z-score is the number of standard deviations away from the mean. Right, those are the concepts we need to know. All right, I'm going to post a worksheet on the classroom with this that we need to complete. We need to be up on this so when we get back, whenever that may be, we're not behind and we can do some quick reviews, go over some concepts, and take our test or quiz however we need to, whenever we need to. All right, make sure you're doing what you need to do. Contact me through email, contact me through chat, do something to get in touch with me if you're having difficulties. All right, we can just chat using Google Chat. We can do a video where I look at your work and you can look at my work. Whatever it takes to get through this, we got to do. It's not a fun time right now, but it's just the way life is. If you need any help, contact me, and I hope everything's going well.